building BI and AI solutions on cloud for healthcare. So we will in detail about what does it take in today's healthcare setup to build powerful solutions that can ultimately benefit the patients out there. I already gave a lovely introduction there, but let me introduce myself as well. So I'm Preeta. I'm a director for data analytics within Providence, India. Providence, I participated in building an advanced analytics group, and I'm part of that as well. And one of the core values that we have in Providence is compassion. And this is something that I personally also believe in. And from an educational background, I have an engineering degree in computer science, and I also have an MA degree in psychology, and I specialize in organizational behavior. So let's move ahead to take a look at the agenda that we have today. We will provide a view of how BI and AI solutions, or business intelligence and artificial intelligence solutions, can help healthcare and for bringing in better outcomes within healthcare. But before we get into that, we need to understand a basic setup of a healthcare system. So we will touch upon that. And we will also talk about the different kinds of data that get generated within the healthcare system. Therefore, what are the challenges that we meet when we deal with this data? Then we will also look at what are the general aims and goals that a healthcare system wants to achieve, and how can BI and AI help to achieve them? And of course, how do we utilize the power of cloud, right? So today we have multiple ways of operationalizing the solutions that we have at hand. That's why we have the term XOps, because there are many approaches to this. And we are also slowly moving towards a self-serve model. So to utilize the power of cloud, how do we also go towards intelligence as a service itself? And finally, it is very important to understand not only the opportunities that we have at hand to build more, but also the pitfalls that one can experience within the space. So let's take a look at what a healthcare system really is and what are the challenges that one can meet when dealing with data. Standard definitions. Health systems are those that are delivering services that improve, maintain, and restore the health of not only individuals, but also the communities at large. Now, this could be done through a very structured approach of having hospital setup, or it could also be the local setup of, let's say, the family doctors that we have. And it need not necessarily include just the treatment of the disease at hand, but it would also have probably not so visible tasks such as prevention of communicable diseases, or understanding and then improving the social, economic, as well as the environmental conditions in which people live. So as per the World Health Organization, one has to have a health system which is very effective and can be effective for a universal level of health coverage. Then there are three main categories of stakeholders involved within that. So these three categories are listed as follows. So the first one being the state. And by state, we refer to as any government organization or any agency that can operate at a central level and also at a sub-national level, so at a local level. And the second category of stakeholders that are involved in the health system are, of course, the providers. And here it could be the physicians, the doctors, the nurses, or the extended network as well. For example, the diagnostic centers or the pharmacies and more. And finally comes the citizen or the service users for whom the care is provided. Now, if we were to take a look at a simplified model, which is based on maybe the US healthcare system, then this model is represented as the patient who avails the healthcare service, the provider who provides the healthcare service, and the payer who is basically helping cover the costs of the service that is availed by the patient. So having looked at stakeholders that are involved within a health system and what a health system really is, let's understand what are the aims or what are the objectives of the health system. as a healthcare provider, as well as the patient that is receiving the health service, it is very important to ensure that the interaction between the providers and the patients is seamless. And this is one of the main objectives that a healthcare system can carry. So which makes healthcare services much more accessible. Second set of aim could be about improving the collaboration within the medical staff themselves. So if there are multiple staff working around the similar healthcare service, then it always helps in sharing the best practices and the knowledge that they have amongst themselves. So we will talk a little bit more about this. And ultimately, this helps in better and faster decision making. It's also important is to help the providers sustain their engagement. And when we mean by sustaining the engagement, typically there is a tendency to have burnout set in within the providers, especially when there is a very high demand for healthcare services. So how do we ensure that that doesn't occur? And at the same time, we have a shared visibility of voice and everybody is able to understand each other's opinion. Next set of aim would be related to improving the quality of care itself. And here we often talk about value-based care, but at the same time, there are other measures that come into picture. For example, is the care being provided under safe conditions? Are there any hospital-acquired or healthcare-acquired infections that are happening in the process? And finally, it is important to ensure that we have a good handle on the cash flow. And there is an efficient way of managing the cost that is involved for providing the service. And this could be around monitoring the operating cost, or it could also be around understanding and maintaining and also growing over time. So here is a very good framework that puts all this together. And for any healthcare system, this acts as a strategic compass to measure themselves and measure their own system's performance, whether they are moving towards the right track or not. So it's a very clean division of the aim, which is around the patient experience, the caregiver or the provider experience, the health outcomes, and finally, making the cost of care more affordable. So now that we have looked at what could be the different aims for a health system, but what are the strategies that can be deployed in order to achieve this? So as per one of the quotes that I come across, and this is from Dr. Rod Hoffman, who's the CEO and president of Providence, that the system needs to solve for. What are they? They need to have strategy for the physician or the provider, the strategy for the payer, and also a strategy for everything outside of the hospital as well. The outreach to the patients is much higher than what would happen just within the hospital. But what does it take to actually go ahead and implement these strategies? And it takes transformation in the decision-making processes. And again, there are, we call this as a 3D approach to transformative decision-making. And in healthcare, the first D here stands for diversification, because the mode in which today healthcare is being provided to different users is varied. So we have something like the telehealth mode of care that is required at a particular point. There could be emergency clinics set up for the need of the hour. So there is a whole lot of diversification that we are seeing, which will involve transformative decision making. The next D stands for deconstruct. And this is about ensuring that not only do we have general facilities, but we are able to construct into specialized units. And therefore, we have experts who are deeply specialized in particular subject areas, and they are then able to make decisions involved within their own area of expertise. And finally, of course, digitize, as in when we are able to take more and more processes onto the digital platforms, it basically bolsters our decision-making processes. So at the end of the day, one has to always remember that for overall transformation in the healthcare system, it is people who need to collaborate with each other. It's a connected world. But technology can be a very critical enabler, and that's what we will talk about. And ultimately, together, this combination can help us achieve healthcare aims. Fundamentally, it is data which is serving as the oil to propel this decision-making process. So we have a very powerful sentence here which says, data saves lives. But how so? How can the data that we are seeing help with decision-making? What are the different kinds of questions that the decision makers come across? So here, first, let's take a look at, who are they? Who's making, all these dynamic decisions? So it could be, now, as we looked at the health system, we have understood that there are too many players here, but just to simplify it, here, there are some examples that I have provided. So it could be the patients, those who are receiving the care, the nurses, the doctors. It could also be the researchers or the scientists, the medical students who are upcoming for the next generation. And also, it could be the financial planners who are taking care of the economic ecosystem, and also the facility planners who try to understand, okay, where should a particular service be deployed. So in our day-to-day work, the kind of questions that get asked to us so that the decision makers can understand more about the data that they're receiving are something like this. So I thought I'll provide, and these are standard examples that we deal with on a day-to-day basis, right? So they could be operational questions. It could be something, for example, what do these lab results look like? How many results does a particular facility churn out for, let's say, prescriptions coming from a specific hospital? Or it could be a research-oriented question where the doctors would just want to understand if there is a strokes facility, then what do some of these patients have in common? Can they be divided into smaller cohorts based on the commonalities that they have? And we've also had a lot of sites that are generated around what does the patient experience look like? So has it been, and they would want to know this at a much more granular level. Is it positive towards a particular facility, towards a particular physician that is available, who are servicing in that area or not? And then it could also, as I had mentioned earlier, be about what is the trend of mortality index that is happening. There is a lot of study which is happening in terms of understanding the population or the demographics within a particular region. So these are also some set of questions that we come across. And finally, it is one of the critical questions, or the last was some of the very, very critical questions that which is how many physicians or nurses need to be deployed in a particular department. And even want to know what should be that number in a given day, in a given hour, in a particular time slot. And then finally, we are also moving towards decision-making processes which help us understand a seemingly, uneventful time. Can we detect an impending, maybe a stroke or a cardiac event, and can we deploy maybe an emergency or ambulance unit at that point? So to summarize, the ways in which data is being used today across the decision makers in multiple points during their day is to predict, let's say, the patient's health, to understand also the genetic risk considerations that need to be, that can be helpful in the course of treatment, to understand the disease better. So we will share a little bit more of details out there. And as time goes by, we are also seeing a lot of information coming in through real-time sensor information. So this is also something that is playing a key role. And finally, the way that data is being used, at the end of the day, it needs to be about treatment and also applying the right kind of prevention policies and putting them in place. So first, we need to the different types of data that comes in order to help with the examples or the questions that we said we come across on a day-to-day basis. So now I have tried to divide the kind of data that comes in from healthcare systems records. The reason being, it is just enormous. So data gets literally bombarded from different directions. So what could that be? So let's see if we can have a flow here. So the first set of data that we see that come in are from the patient themselves. So here there is a standard terminology and standard digital version of the patient records that come into use, which is the electronic health record. Now, for every patient encounter being every time a patient receives a medical service, the corresponding information is captured in the form of an electronic health. Major source of data that comes. Then it could also capture information about compliance, and here compliance could be related to getting a consent form signed or an authorization form signed. So we have data related to that. We also have data around the lab investigation report. So this could be the measures or the results that come in, or there could be a variety of pathological reports that are sourced. And in the same line, we also have information coming in the form of images. And one of the standard formats of images that is used within healthcare is the digital imaging and communications and medicine format. And here we could receive data which is about the X-ray or the ultrasound or the CT scan and MRI reports. Then there is also information on the medical charts. So the daily nurse records, prescriptions, the dosages that are applied. And there is a very rich content that is available out there in terms of the notes taken by the physicians. This could be during an operative procedure, or it could be during a consultation, or it could be just the treatment history that is elaborated in by the various physicians who are in touch with the patient. The discharge summary is also a very good source of information for us. So here we get to know about not only what has taken place within the facilities, but also what is recommended as care beyond the facility, right? So it is about the long-term recommendation of care or what can be done within a home setup or even a hospice setup. And as I said earlier, one of the main sources that we are also seeing is in their regular day-to-day lives, can we collect Internet of Health through Internet of Health things, data in real time? And this could be about the vitals of the patient or other biomarkers. So far we spoke about the data that can be collected from potentially even a single patient during the course of their treatment. But now, there is also the whole healthcare system that is generating data. What is that all about? So I have again categorized them into multiple areas. So we will quickly take a look at each of them. There is information about revenue and finance. And this could be the details related to the bills or the charges that are applied for that service, the set of services available. And it could be about what are the insurance claims that have been submitted, or about the payroll, or how do we sustain this healthcare system with the given payroll for the different staff. The next set is about the facilities, staff, and the schedules also. So here it could be related to procurement of materials. It could be related to the timekeeping and schedules. Or, as I said, there are to understand the patient's experience across each of these facilities. Surveys are taken periodically. And now we have seen that a lot of data comes in the surveys, and this could be in the form of numerical data, categorical data, or it could also be textual feedback, verbal feedback that is written by the patient. Then moving on to pharmacy. So again, we see that whenever there is a huge pharmacy setup, which is also owned by the healthcare system, there is the entire supply chain involved, which is again received as information for us. And here we could get additional data related to maybe the drug composition, or it could be about the stocks that are being managed across the different points in the supply chain. And here it is one of the very important things that we have in order to help data standardization is to get the medical vocabulary standardized. So there is data available out there, and now this differs depending on the health system. For US health system followed. So for example, for the symptoms, there could be codes that are followed, or there is for the procedures, we have the procedural code coming in, and the same goes for the diseases themselves. Furthermore, on the medical data, we could also get information based on the observations that are happening on the devices. This could be the devices within, let's say, an ICU setup, or even in the rest of the areas within the facility. Finally, we have to touch upon this very upcoming and emerging area where, probably there's going to be an explosion of data that we are going to deal with, which is related to genomics. And here it is not only about the data and molecular biology related to the disease-causing pathogens. So that is also part of it. But it is also extending towards human genomes. And here we are seeing a lot of opportunities that can come our way over time. So as it is, I think we've looked at all of the information coming in when the patient goes through a treatment, all of the information coming in from the healthcare system itself. But there is also a network of hospitals and a network of clinics. So for example, in Providence, so we have about plus network of hospitals and close to 1,000 clinics. So you can imagine the multiplier effect that is taking place here. There are also organizations, and I've taken the example of Truveta here, who have started understanding the importance of data sharing. So here is a consortium that has been set up across, at this point, 20 different healthcare systems, where they are encouraging and managing mutual data sharing. And of course, there is the whole fundamental premise that when the data is shared across multiple healthcare systems, the data of the patient is de-identified. So for all the individuals involved in the whole information that is being shared, it is ensured that any of the personal identifiers are removed, and after that, there is mutual data sharing. Why is this done? It holds tremendous potential in terms of advancing health research. So we will see a little bit more as we move on. Okay, so what could be the challenges? So we have seen the different sources of data that one can deal with, but what are the typical challenges that we come across? And some of this are, by now, pretty much something that one can guess. So the very first one, for example, the content that is being dealt with. And to be very precise, the variation in content that we are seeing. Second, text. So as I was just mentioning, once we have data coming in from multiple different sources, and it is also, let's say, de-identified, so we don't necessarily know who this information belongs to. So which means to a large extent, the data could be out of context. Now, however, it is quite helpful if we start understanding the context in which the data is presented. For example, we do not need to know specifically who that person is for which the data is coming in, but if two different record sets are here and I get to know that they are about the same patient, then that is a very So here, what we have is that sequence in which the data is received is very important in healthcare. So it is important for us to know whether, let's say, a particular drug was administered before a symptom appeared or after the symptom appeared. So, and even within the course of the treatment, the data keeps changing, and then, of course, over a period of time. So how do we deal with that? And then there is a critical aspect around compliance. So on a very periodic basis, different organizations, mostly government organizations, come in to ensure that the regulatory compliance is up to date. And every healthcare system then needs to adhere to that. And how do we keep ourselves up to date as well? Of course, all of the above lead to a higher degree of cost potentially, and the volume of data that we're dealing with is high. And over time, how can it cross the boundaries? So we mentioned data sharing, but how can that happen? So here is where we feel that, coming back to the topic, which is business intelligence and artificial intelligence, can help us tackle some of these challenges, as well as putting them on cloud can sort of give us a bottom-up approach on tackling these challenges. So let's take a understanding of how this is possible. And here, at first, I'll provide a refresher, which is a very short one. And then we will look at some of the real life examples in which we are tackling with these problems on a day-to-day basis. So in terms of refresher, so the kind of reference architectures or architectural patterns that we are seeing that are being employed today in terms of business intelligence combine both strategies, right? So we have the data warehousing strategy. We also have the data lakes available. So the hybrid architecture is what we have seen is quite popular and is also effective. So in this hybrid architecture, we would also involve adding a semantic layer, so which is probably going back to the fundamentals of having, let's say, an in-one-dimensional model. And here we are able to understand that if we create data marts which are specific for a particular department, then that is also helpful for them to understand. The to have in place is related to supporting distributed parallel processing. And here it could be a Spark-based architecture or a massively parallel processing architecture. What do we do about when it comes to the AI solution? Now here, the reference that we are making to AI is I've given a very simplistic format here. So at the heart of all of the AI solutions, we would have or an approach that is created by, let's say, the statisticians or the mathematicians. Or in other words, we also have the data scientists. But the heart of an AI solution is the algorithm itself. So once we are able to come up with the algorithm that is capturing the pattern of the data, then it can be translated into a model that can, again, be in a well-defined. And the packaged AI solution is something that we will look at. It requires a lot more components and capabilities to be available within the environment where the AI solution is being deployed or is being used or even being designed and developed. So AI solution at the end of the day is about creating an algorithm or a model that can learn from the data. And this is where, there is a spectrum of learning that is applied. So I have called out a few here, which is related to natural language processing, representational or machine learning, and also deep learning. Employ all of these techniques when we deal with the data that we've just talked about. But what we have definitely seen is when applied in combination, there are very impactful and powerful insights that are generated. Let me give some examples now. One of the problem statements is related to combining all the data that we get from different demographics. And we also have data about the insurance claims generated within these areas. And of course, as I mentioned, we have the patient details and the patient encounter details. So using all of this, can we create format of delivery could vary. It could be a visualization that is provided in terms of a dashboard or even in terms of a geospatial visualization. But can we create insights that can help the facility planners understand the needs of a particular by looking. So here we have worked on, or we are even continuing to work on this problem statement, and we apply both the methodologies as I mentioned before. So we source the data from multiple different areas, but we also try to estimate what could be the demand in a particular region and project the services needed out there so that the planners have this data ahead of time. Next set of problem statement, and here again, this is a huge category. I've touched upon it a little bit earlier related to the survey information that we get. But then again, we have seen that there is a huge demand for understanding what is the patient's sentiment, not only related to, just understanding whether it's positive or negative sentiment, but we have solutions now built which are talking about what is this positive sentiment addressed towards, what is the subject behind that. And again, once we have that information, we can store it back into, let's say, an enterprise data warehouse location, where it is further disseminated to different stakeholders who might be interested in that particular information. So this is another big area of interest for us, and we are constantly working on this one. So this is related to understanding the cash flow or the revenue cycle. So here, one of the ways in which we are helping out is related to predicting the kind of cash flow that one can see at the end of the month. And if we can do this maybe a month in advance, so that the various regional CFOs or other critical decision makers can go ahead and deploy different actions based on that. So for example, if they have to drive further rigor in terms of insurance claim collection that needs to happen. So that is another area where we have seen that deploying a predictive model has proven highly accurate. Now, again, we don't work in isolation in terms of, okay, here is an insight into what can happen in future, but we also go ahead and provide a dashboard view, which is very intuitive, so that they can further drill down into maybe a particular grain that they are much more interested in. So together, we have a very powerful dashboard that is available for them now. Finally, there is, and again, these are just a subset of examples that we are working on, but the last one that I'm going to talk about is also a very critical one. This is related to care management, or we work hand in hand with one of the stroke medical centers. And here, the critical problem statement is related to understanding how long is a patient likely to stay within the facility. And this is a critical piece of information because based on the risk factors that one becomes aware of at the point of arrival of a patient, better facilities can be provided to that patient. So they could be assigned maybe a specialized nursing facility then during their stay. There is also important metrics related to how long does it take for, let's say, the patients to go from the door of the facility to the point of the needle, right? So to the point of when the first immediate medicine is applied to them. So in this case, it is known as altiplase, which is very important. So it is very critical for them to measure the time taken between door to altiplase, for example. And again, we have created a solution or a product in this case, which can help maybe the stroke coordinators or also the nursing facilitators within that particular medical center to look at all of this data in conjunction. So not only can they probably register the stroke patient at the point of arrival, at the same time, they can also look at the other metrics which are important at that particular point, and also be able to understand what are the recommendations in terms of, let's say, the length of stay, or over time, they could also understand what is the kind of readmission risk that is posed for this particular patient. So what we have learned is that all of these problems are not something very unique to just one particular healthcare system. It is something that all of the healthcare systems out there are grappling with. And our learning is that the more well-defined a problem statement is, the better we are at creating a solution for it. And also higher the involvement of the stakeholders. So if we are working hand in hand with people who are at the end of the day making these decisions, then we end up learning more about it and we start applying it in our solutions. And I've given a general understanding of where we stand in terms of all of these solutions that we have in this particular matrix. How about the power of cloud? So we spoke about creating the solutions. It is very powerful to merge the BI and AI solution, but where does cloud come in? And here we have seen that one of the critical ways in which cloud helps us out is, of course, to operationalize all of the solutions that we've just seen. So, as I said, the learning has been that deriving insights from structured as well as unstructured data is good when we have the hybrid architecture, but also when it is cloud-based. So here we have a list of capabilities that in order to that we have just taken a look at. And it is not just, I think what we can understand is that it is not something that happens overnight. There are multiple components that are involved in ensuring that this operationalization happens the right way. So these components could be about, let's say, having the right data engineering capabilities. So we ensure that we have an efficient orchestration setup on cloud, which can also be metadata driven. And data standardization is a very critical component, especially when we are looking at data sharing across multiple different parties here. Having more advanced analytics capabilities. So can we have those semantic layers? How is the data modeling setup, which is more semantic in nature? And also, do we have multiple different ways in which we can store or deal with the data? So I had mentioned that we could have geospatial data if we need that, or we need to have support in terms of document DB, or we definitely require a graph DB setup if we have to have some of the models working in the long term. Ability to have image processing in place and ensuring that all of the feature captures have a very efficient mechanism, and we have best practices set up in terms of that. Another area which we also have added into the set of capabilities is related to constraints programming. So we have people working on operational research problems, which can help us with some of the scheduling problems that I had mentioned earlier. Now, in terms of cloud engineering capabilities, and here is where I use a term about XOps, which is a general term out there, which can combine all of this together, right? So ML ops, data ops, as well as dev security ops. So we need to ensure that all of these best practices are in place for us to have a robust solution over time. Data governance, which is related to having the data protection as well as the compliance part of it taken care of. And there is also a support needed in terms of multiple different latencies. So can we have the batch processing done? Can we have near real time, and also a streaming platform that can be supported? And finally, we have spoken about the data science components and the visualization components that come into the picture. So our learning has definitely been that when we are looking at building an overall analytics platform which is on cloud, then it has to be all inclusive and it has to have all of these components. And today, luckily, that is possible. And as I had mentioned earlier, another important piece is once we have these solutions on cloud, that we are able to seamlessly interact with our stakeholders at all points in time. So it could be during the design or development or evaluation, or after, of course, dissemination of the insights that we have generated. But it doesn't end there. It is a completely cyclic and iterative process. So a constant involvement of stakeholders with the respective tech experts across these different regions provides us the effective solution that we are looking for. Fine. We have, let's say, the basic setup of operationalizing the solutions on cloud, but how can we take it to the next level? And this is where we talk about having intelligence as a service. So here is a general layered architecture of how intelligence as a service is being enabled. And we are following this sort of a setup that I have put in here. So the building blocks become ensuring that you have the platform which is available on cloud that can deal with all of these multiple data sources, and it is making data available in a cleansed and consumable format. The next set of layers, we need to ensure that we have a way to create an algorithmic engine which can work hand in hand with the semantic data layer that we had mentioned. The next set is related to how we package all of the models that we have. Again, this could be an AI-driven model, or it could be a BI-driven model. But at the end of the day, can we package it to be API-enabled so that it can be shared further? We also try to see if any of these models can be shared in the form of a reusable library. So that is something that is very important, and it's currently work under progress. And we also, once we have the ability to share all of the insights that we can generate in an API format, then of course, the final set happens to be lighting this up in the whole workflow that is being used by the end users. Now, as we have seen, the users themselves can be technical or non-technical. So being able to integrate our insights very seamlessly in a format that it doesn't hinder, but it enables their processes on a day-to-day basis is important. So if done right, this whole setup can help us take intelligence to the next level, and that can light up personalization when it comes to the understanding of the data that we have. And also now we can provide the ability to answer a completely new set of questions that will start appearing when these disconnected data sources are put together. With that, I think take a short recap on what did we learn, how did we tackle the challenges that we have seen earlier. So we saw that we can cut through the noise. So if we are able to, we are getting the overwhelming amount of information, but with the solutions that we have in hand, we can make sense out of it. We can also provide the required contextual relevance. So we have seen that it is possible to look at the text or the image data that is coming in and be able to contextually put that in place for the users consuming that insight. It also helps us to avoid the errors that is otherwise possible if a particular decision has to be taken by consolidating the data in a manual manner. So that in those cases, human fatigue often sets in, but now we are able to offset that, and the processes that we have in place can also spot anomalies very fast. How does cloud help? And here is the bottom-up approach to tackle this, where we can have all of the automated checks put in place. And if we have the appropriate level of engineering excellence, then this is going to help us not only have the data protection standards on cloud, but we can auto scale and use the flexibility that cloud provides us. So we can control the costs depending on the demand that we are seeing. And finally, as I had shared about intelligence as a service, so if we can enable that, then we can further reuse and not only have all of this intelligence done in silos and probably have duplication because of that. But with cloud, we can now have reuse enabled to a much larger extent. In conclusion, let's take a look at what are the opportunities, but also what are the pitfalls. So with merging the two solutions and having them on cloud, and this was something that was mentioned, I think, way back in the introduction, I heard this, where now we are able to create dashboards which have very powerful narratives. So the users can now not only look at a static dashboard which is talking to them about the trend, but also further look at what is the cost behind the particular trend. So the dashboard is providing them a narrative versus the user having to go out there and look for the information themselves. The algorithms are definitely making the data more context rich, and when we are able to come into a stage of intelligence as a service, we are also able to integrate them into products and services. And over time, we can auto-scale using the analytics platform if they have all the capabilities that were listed. So from a technology standpoint, all of this can help us with the aims of ensuring that we are user-focused, we have the product mindset, and that we have end-to-end standardized platform, which can take care of the entire cycle, and which can also go beyond and ensure that we have the right checks and balances put in place. But together, ultimately, they do help us achieve the healthcare aims that we have spoken about. The opportunities. So what we can further work on, which we have not yet done, but we are in the process of doing that, is when it comes to normalizing the data, or even before we end up storing them into, let's say, a data lake or a data warehouse formats, can we use AI to normalize the data further? For example, we get all the text information. Can we map them to the diagnostic or the disease codes available? Of course, with a particular confidence level attached to it. So what this can help us do is it can help us scale over time, so that once the data is normalized, this can now be used in multiple different ways. Fuzzy relationships. So here, I think this is something which can really come in hand when we are talking about enabling interconnected scenarios, right? So today we have seen that there is a very hard and fast relationships which we are able to work with clearly. But what about those which are somewhat not 100% related to each other, but they do have some correlation? So here, if we are able to understand this and save it, then this can further help us answer a lot of other questions over time. And then historical data treatment. So there could be an intelligent way of managing any kind of requests around historical data treatment. So we've seen that at times, let's say to keep up with the compliance standards, we do have asks related to going back and looking at maybe data from the last 30 years or so and start annotating. And this could be about, let's say, let's figure out what was the particular cancer stage that needs to be annotated against a given scenario. So instead of employing, again, a lot of manual effort or even simplistic automated effort, one can employ AI methodologies and then go back and annotate and store it in our respective tools. Finally, what are the pitfalls? This is the most important pitfall, which is one has to constantly work towards eliminating it. We may not get all of the information. There is always data gaps, and this could be related to the demographic diversity that is out there. So the bias that tends to take place within the algorithms, or if we are able to only cater to a specific subset, then that is an issue that one needs to be always aware of and try and eliminate and to bring equity. The next set is, of course, as we are aware that there is the healthcare data is one of the highest targets when it comes to cybersecurity. But then we ensure that PHI data is handled appropriately. We again employ methodologies which are related to, which are again not manual, but automated to a very large extent. But then there could be a potential lack of accountability if we are not saving our data in the right manner. So one needs to watch out for that, and we need to ensure that we have, again, the right kind of checks and balances put in place. And finally, the most important note, which is we can see that over time, if there is a lot of dependency that is taken on the tools because we are able to make those advancements, then an automation complacency can set in. So is there an over dependency that, let's say, the clinicians could have on top of the tools that is helping them with the recommendations and helping them with the decisions? But that automation complacency is something that one needs to, again, fight to eliminate, because new information keeps coming in, and the system can only be as updated as what it learns from the human counterpart. So with that, I would like to cut to a close, but with a reminder that at the end of the day, it's the people behind it who need to make the important decisions. Technology is a very critical enabler and can help out in many situations, but it's only together that the healthcare aims can be achieved.
Great. Thank you once again, Preeta, for the session. Now, I think we have quite a bit of insightful questions that we had in our chat box while we are doing a presentation. So we'll get started with that, where we would like to pick your brains on. There's a question regarding the mutual data sharing consortium. Is the data sharing happening in real time? Is there a common platform for this data sharing? If so, what is the common standard being used?
Okay. So the first part about is, what is it that is being done in terms of real-time data sharing? So at this point, it is not necessarily real-time data sharing. It is a batched effort. So each of the healthcare system that we saw within the consortium is responsible for ensuring that the data is shared, but not at a real-time basis, but on a periodic basis. So we do that as well. So we have our platform where before we share the data to external world, we ensure that all of the personalized identifiers are removed. So the next set of question around what kind of platform is being employed in this particular case, I can talk about that. So there are again, it is definitely a cloud-based platform, but then what we further need to look at is what are those, let's break it down into capabilities. So one, as I spoke about, is related to de-identification. Now, again, this need not only be about the structured data. So we need to ensure that all of the nodes that we have also are de-identified. So that is another important step that gets taken care of. The next set, which is employed within the platform, is related to having a common vocabulary. So different healthcare systems could have different medical terminologies available, but can we standardize that? So there are standard codes which are available out there, which are then applied in this platform before the data sharing is done. Then the next set of techniques which are applied on this platform is definitely related to AI/ML. Okay. So because there is a huge, enormous influx of data that comes in, so they have multiple white papers published on this related to what kind of AI/ML techniques are being employed within this platform to make sense again. So if the question was related to, what is that platform all about, which product is it employing, I think I'll refrain from going into the details of the product itself, because there are multiple cloud offerings available right now out there. So different people partner there. But these are the different techniques or capabilities that are applied.
Got it. Thank you so much, Preeta. The next question is, since we are sharing data between different companies, if a person is associated with multiple providers, will you be able to identify them, or they will be considered as a different records? What are your thoughts on that?
It's a wonderful question. In fact, this is exactly the kind of example that we have when it comes to data coming in out of context. Answer in a very short format, is it possible to identify that it's the same patient coming in from different providers and develop the algorithms for it? But what will be the confidence of us capturing that particular record would depend on over time and what are the different that we have fed into that algorithm. With required training and feedback, we can reach to the extent that we say that, yes, these two record sets that are coming in from different providers are actually the it looks like it's a similar, therefore, there is a certain percentage or a degree of confidence with which we can say that yes, this could be the same person, but not in all contexts. So we can achieve it, but not in all contexts.
Got it. So how is genomic data captured? Can you share real life BI and AI example for the same?
Very emerging area, and we are in fact learning here ourselves. So again, the type of tooling that is used within genomics is different. So what they would use in order to study the microbiology aspect, they would have a different set of tools set up for it. But once the data is set, if we are to capture it in again a very structured format, then we can translate. So today we again have offerings from all of the major tech players who give us APIs for genomics also. So we can apply the same, and again, there would be a lot of evolution that is coming on the API as well, because as they find more in the labs, their data contracts will have to get updated. But we have one of the basic fundamental frameworks are now available. So with that, we can then standardize and put it into whatever way that we deal with the rest of the data that we have in place. So again, as I said, there is a lot that we need to learn here. It was only, I think I was just reading somewhere yesterday, or I think one of our team members had shared this with us. So today we know a lot about the proteins within the human genomes that are available, but that forms only 2% of the entire genomic information that is actually present. So even in terms of medical research, we have not made major breakthroughs. But whatever we do understand, we can translate that into data and make more insights.
Wow, thank you so much for that. We have a follow-up question on that, right? Do you already have a system built to consolidate data from all the verticals that you mentioned over your slide, from facilities to genomics? If so, what concept have been used to consolidate and correct the multi-vendor data?
Multi-vendor data, okay. So, yes, in fact, this is a very relevant question when it comes to healthcare. What we have seen is this tendency or this pattern for many of our larger healthcare systems to go back in and part multiple offerings which are available to us. They could be large, small, medium. And today we have seen in terms of providing data, aggregation of data, we have vendors there, or in terms of providing techniques. So many of the techniques that I've spoken about today are also available from third-party vendors as well. So here we have to go back and first of all, not only, so there are two approaches, right? One is how are we collecting data from multiple vendors and then standardizing them in our data platform? And second, who are the data vendors that we need to rely on? So both need to be tackled. So coming to who are the data vendors that we need to rely on, I think that itself is a conversation and evaluation process that goes through. There is an entire checklist maintained to first come in and narrow down the list of vendors that we should, at the end of the day, start interacting with and integrate with. That depends on the quality of the data that we are providing and also how well integrated they are within the system or the workflows of the healthcare system. So once we have that, the next set comes in about actually integrating from the multiple vendors. So one of our teams, in fact, I had taken this example of, let's say, the survey. So one of the active areas of work that we are having today is to consolidate all of the vendors that we have on the survey area, because we don't rely only on one, but there are multiple different vendors who provide us that information. And typically the surveys are done by a third-party vendor and not the, let's say, the provider who's involved, to eliminate bias. So when that happens, we have created our own platform to try and consolidate all of data that is coming in from different third-party vendors. The plugins that we have, the integrator or connector components that we need to make across each of these vendors would then have to vary. So again, we try to standardize it. If we can come up with the regular 3 or 4 connectors that are involved and ensure that third-party vendors are applying them, then that is great. And once they do come in, let's say the connection problem is resolved, then the timing is, the refresh times are an important area to tackle. As I mentioned, the timeline is important. We need to ensure that in this example, the survey that is coming in is not entirely outdated, it is not expired, it is still a relevant data. So we need to ensure that the refresh timelines are taken care of. And finally, there is a lot of rigor again around once we have consolidated, is it going to the right set of parties, right? So who needs to view this information? So do we have the right views set up on top of it? That is where our own custom engineering comes into picture. So we need to not expose the data as it comes into the users, but have the relevant views in place. So we have another area.
Got it. So also the next question is regarding, so the clinical data is usually not in a standard format and may follow different ontologies. Do you think data scientists spend most of their time in data curation and management rather than driving insights? What are your 2 cents on that?
So do I that, or do I think, can they spend a lot of time in preparation? Yeah, they could spend a lot of time in preparation, but is it happening? No, in fact, because we deal with a lot of data where there is a lot of awareness already set and related to the ontological reference that was made here. So there is a very close integration or collaboration that takes place with all of the people involved. So it could be the experts who are telling us that here are the medical standards or ontological mappings that you need to apply. And we do have a lot of engineers working hand in hand with the data scientists. So they can be ML engineers or analytics engineers who help us to a very large extent to ensure that the mapping is put in place on the underlying data on which the algorithm then needs to be created. So we have those help available in place. So in reality, definitely some part of the time has to be spent on data processing, but to ensure that the basic pre-processing steps are done, but not all of their time is actually spent on that if we have the right collaborators in place.
Got it. So this question is regarding the slides where you talked about the revenue circle, right? What is the current baseline of Providence cash conversion cycle? Has there been any insights in terms of digitization effort done to reduce the cash conversion cycle to drive an optimized free cash flow?
Okay, so here again, there is a lot of, it is not in terms of cash conversion cycles. There are certain standard cycles and timelines that one has to follow, which would be related to the rest of the ecosystem. So we have to follow that. But there are cycles such as payments, what the payments that we are receiving back from, let's say, the insurance partners that we have. Those cycle times are something that we can actively try to pursue and optimize much better. But the financial cycles is something that we have to follow based on what is required. Now, coming back to the other cycle times, let's say it could be related to the insurance claims, or it could be related to the billing cycles that we have in place. So yes, in terms of digitization, in Providence, I can speak for Providence, we have an entire EHR setup, an entire clinical revenue cycle application setup, which helps us in ensuring that the front-facing applications are digitized. So that in itself can have a lot of impact in reducing your cycle time. But as I had mentioned, we also have the whole insights team available now, who will take a look at not only what is the cash flow or the charges that we are making to a corresponding insurance claim provider, or we also look at how frequently we are receiving it back from them. Who is paying on time versus who is not? Who is regularly defaulting? We also look at data related to what kind of debt is a patient incurring, can provide us with. So is there a bad debt that we are getting into because of a particular set? What is the write-offs that we have to put in place? Providence being a non-profit organization, we also look at the charity write-offs that one has to do. So not always we can rely on the cycle time, and not everything can be claimed back. So we also look at what kind of charity write-offs we need to do. all of this is powered through data and dashboards and the insights that we generate. So they are not decisions that are made in silos. So yes.
Okay, got it. I think this question is regarding the last but one slide where you talked about the pitfalls and opportunities, right? I think one of the pitfall was automation complacency. So the question is that why is it a pitfall? Isn't it the goal of AI to reduce the dependence on human interpretation and action and gradually mature in process? And don't you think that the automation complacency should be a norm as the model matures and has a good confidence level? What are your thoughts on that?
Thank you for asking that. So what are my thoughts on that? I can tell you that. This is a huge debate. But my thoughts are this, right? So are we there yet? Definitely not. But even, let's say it matures. There was a point right before that around catching accountability. I think the 2 points are highly correlated because one, a high degree of automation complacency sets in. Who do we attach the accountability of action on? So let's take a very futuristic, or probably even now it's happening in certain areas. Let's say we have a remote surgery happening where but they can do a remote surgery using the robotic arm. All of the tooling that we have in place aids the surgeon at the end of the day, but the action needs to be taken by the surgeon. If there is anything that goes amiss, we still have a lot of accountability that can be taken by the health system. The accountability of the action on, let's say, an algorithm or a tool. So although there would be a lot of maturity that will take place in terms of the tools coming up and being highly reliable, but in which cases can we completely rely on them versus in which cases do the actions still need to be manual? We can take the decision based on that. It can aid, yes, this is the right action to make, but can the algorithm act? Can the automation act? No, not yet. So, but definitely there are other areas which are probably not as, based on the risk that we assess, they're not as high risk. We can definitely go ahead, and if they are robust enough, we can employ them. These other areas, I mentioned a little bit on that. So, for example, let's say anytime we have onboarding process, so a new caregiver or a new provider who comes into our ecosystem. So I think in one of the slides we have caregivers who are coming in. So that's the staff that we have to maintain. But let's say they are having certain issues. Today, if they send in issues maybe over emails or raise a ticket for it, but do we have enough support system to look into the caregivers' issues and help them? And probably resolve their digital issues for that matter. So for them to come on board, maybe not. So there we can go through all remediating it and then have that end-to-end cycle. Where here we are having more positive action. We are trying to see, okay, can a self-remediation take place and can we help them without any manual intervention? There, for sure, if your tool is reliable enough, go ahead. But in healthcare, we have a spectrum of risk. We have to assess that. So, yeah.
I think your question is answered by that. Thanks for that. It's also in terms of what is your biggest challenge as a healthcare tech provider that you're facing that is yet to be resolved?
Challenge that is yet to be resolved. So, this, right? So, I think we spoke a lot around based on, let's say, the US healthcare system. But we want to look globally, right? So we are not yet there. So, and what we spoke about was universal health coverage, which involves, not just those areas where standing of managing data. We have the, EHR formats which capture digital version of your paper charts, etc. But what about all of the other regions? So in many of the other regions globally out there, data is highly fragmented. We don't have the digital formats that is required for us to get to the next level. So the biggest challenge that all of us have right now, and it is definitely not solved, and that's what we are working towards solving, is how do we make this global? Can everybody benefit out of all the tech that we have, or all the new research ideas that we're coming up with?
Got it. What are some of the focus areas of data science by payers, providers, life sciences companies, and few top use cases in individual areas which one should focus on based on your experience?
So there are where data science can be employed. And in the question, I think we have covered all three. So we are saying payer participation. What is interesting is from Providence, we come in from the provider angle. So we have a lot of companies out there who have a whole lot of insights around the payer angle as well. We do get the payer angle by interacting with them, but we do a lot from the provider side. So what kind of data science can be applied in all three? I think that the list will be huge, but then I did touch upon some of those areas. So let's say one around the provider, right? So from the provider side, as I had mentioned, a lot of decisions that we take, predictive scheduling is one of the biggest areas. So let's say we need to understand what kind of schedules need to be published today for the various staff that we have in place. So we employ data science out there. So we get to know in advance, can we project that this is the supply that is required in a particular department? And we do that as of today. So accuracy, of course, is something that we need to build on. Not all of this would be accurate, but that is from, let's say, a provider angle. We need to maintain the staff and schedule. From a payer angle, can they predict the influx of the charges so that they can stay on top of what kind of denials are expected to happen versus what kind of payback that they need to provide? So again, projecting the denials is one of the problem statements, just probably giving the top one, right? And then finally, on the patient side, one that I really like is related to continuum of care. So for patients, it is important to now start self-equipping them. So we are having people working on, devices that can help them do that. But do they have to do it completely on their own? Not necessarily. So there can be remote management of that. Patient can be constantly in touch with them. So if they are seeing a particular vital going on, and if they fall into a high-risk category, can there be an automatic set of recommendation that is provided to the patient? Can there be monitoring of their lifestyle and therefore recommendation at a lower level, which is provided, which is again not holding a very high decision-making potential? So can that be done automatically through data science? Yes. So recommendations can be provided. So again, these are just probably one on each of those sides. But yeah, there's too many to even list right now. Yeah.
Absolutely. But thank you so much for providing that few of those use cases, right? I'm sure that it was definitely useful for us. And also in terms of achieving the better health and narrowing healthcare gaps is the prime intention of the entire healthcare industry, right? What is the advantage to a citizen like me with these emerging technologies being put into the use in healthcare? I think you covered quite a bit during your presentation, but do you have any other things that you would like to add during this question?
Yeah, one thing that I would like to add is I did not touch upon our pandemic situation in this entire thing, and it was sort of intentional, something that it is just set into all of us by now. But to answer your question on how did it help, I think we witnessed it in the last 2-3 years of how technology can help us in a very, very real way, right? I think probably by now, many of us as individuals have availed it. But in fact, that question, Aishwarya, is something that also brought me into this whole space, right? So as maybe or one of our family members is a patient and we are supporting them. So how can we make for people at the end of? And here we have to remember that as soon as a disease or an illness setting, so whoever comes into this healthcare system as a patient, they're already in a certain set of pain that they're undergoing. So can we reduce the pain that the processes add on top of their existing? So that is an aim that one can have, and which is happening. So imagine that, just to support a family member, you have to, stand through a number of queues or wait in different, spaces before you actually get the results that you have. But here we can optimize. Let's say we have an integrated data system. The patient's chart is automatically come up whenever you go to a diagnostic center, and yes, I already have your information, so I don't have to carry all the files around. Or maybe a diagnostic center is understanding that yes, today I'm going to get a very high demand, or by tomorrow I need to staff up much better. I need to have these equipments that need to be in place. Or forget about being planned. They know that there is going to be a delay, and they can at least give that expectation. Okay, don't wait around here. It's going to take us some time. We will give the data back to your doctor. So that kind of experience is very important, which is possible today, and that is going to benefit folks on the ground like you and me. So I'm passionate about that actually. Yeah.
I think you made really valid points. I think in terms of the wait time, if it can be applied all across India and if it can be reduced, I think that is something that any patient would look for, right? And for the care providers as well. Thank you for that. Hopefully, we have a better infrastructure in place soon. It's there already, but hopefully much better in the upcoming years for sure. Also, we are talking about, I think in one of your pitfalls, you also talked about the security infrastructure, right? We know that we have been processing a huge amount of healthcare data, but how is the current cloud security infrastructure designed for it, right?
Yeah. So this is one of the fundamental topics. So if this is not, and this can be a separate session probably at some point, but it is a fundamental when it comes to healthcare. So I'll break this down further. Maybe again, how all of us who are involved in a healthcare technology area can contribute towards this, right? So as an engineer, the first step is that it starts with me. So as an engineer, I need to ensure that I am practicing all of the best practices that are put in place. So I had mentioned about a term called DevSecOps, right? So it's not just about DevOps anymore. It is DevOps with security. So when I am running my code or I am developing for a particular application, have I ensured that all the vulnerability scans are run? Have I ensured that the architecture and design is as per the infosecurity practices that are published out there? So we do have checkpoints around, further reviews from different experts. So that is another, one is the responsibility of the engineer to make sure they practice. The second then comes the governance of whether, the practice is maintained or not. So enforcing it. So we have a set of experts who not only enforce all the policies and ensure that, the review processes are in place, but who also stay up to date about what is coming up next. They constantly monitor and see that, any vulnerabilities are mitigated at the right time. And if, all the levels of patchings are applied at appropriate intervals. And if there is a particular attack out there, the response time, how soon can we respond to it, and how soon can we protect ourselves. So these techniques are maintained by our experts, and we have cybersecurity experts within. The third angle is also the offerings provided by some of the major tech companies out there. So within the cloud offering, if we are really looking at some of the data which is highly confidential, then you have a private cloud option as well. So if there is a right amount of balance around, your choice of, okay, here is a private cloud option that I have, or services that I need to enable on a public cloud setup, then how do we do that? So you have those options, and we can select based on it. But key is one needs to be aware of all of this. It is a fundamental, I think, the 101s and 201s is something that we often conduct. So the trainings have to be conducted within the organization.
Got it. So in line to the same question, right? So What about the companies who are just getting started on processing a huge amount of data or moving a huge amount of data to the cloud? What are your 2 cents of advice for them?
In fact, we were one of them a while ago, so we have some learnings from that. So it is an important step to migrate all of the data, but sometimes it can get monotonous. So applying the right level of automation, and not everything has to be, done in a very mindless way, right? So you cannot just say, okay, this is just data migration, let's just go ahead and move it from part A to part B. Apply our engineering thought processes there as well. So can we create some reusable components? So if there is enormous amount of data that you have to deal with, there is validation of data that needs to take place after it is migrated. First, let's create the tool sets, and then approach this in a very smart way. That okay, I need about 5 tool sets that I can really apply. Let's run this first. Let's do a migration scan. What are the different spots where I actually need to make a change, and only do those. So that is one. Definitely invest in the tool sets that you need to do before the migration. Second is trying to see if we can get any out-of-the-box methodology. So not always it is required that what you started with is how you need to end up also. It doesn't have to be the pure lift and shift, as we call it, right? So let's say on-premise, you had a particular architecture. But when you go on cloud, there are a lot of out-of-the-box services that are available to you, which now you can utilize in a different way. So can you apply and rethink the design a little bit before you actually do the migration? So your end state can really, use the power of cloud versus just do a little shift. So,
got it. I think with the interest of time that we have in hand, I'll have one final question for you, Rita. The partnership is something, it's key for transformation and disruption, at least for the last few years. Right? We have seen it over various companies that have come. What are the key partnerships that healthcare industry should focus upon? And you can also probably talk to us about the ones that Providence benefited out of.
So I think the thing that I ended with was it's a connected world, right? So this is not a problem that can be tackled in a subset. It has to be done in a connected manner. So the partnerships that we can avail, and here is where I'm very happy about it, that we have seen a lot of eagerness. Everybody is very eager to partner with each other, different organizations, different agencies. So that's an excellent opportunity that we need to make use of. So the kind of partnership can occur, one which I did mention related to, data sharing. The second could be related to with the technical counterparts themselves. So all of the major, the tech majors. So we do have partnerships where we try and make their technology a little bit robust, and in turn they profit out of that as well. And we get, through that partnership, we get early peeks into what is coming up next and what is it that we can apply within our ecosystem. So this could be all of those offerings that we have on top of cloud as of today. So a partnership with the tech. Third set of partnership would also be with the individual subject matter experts, right? So let's say I have within my ecosystem, it could, and here now we have the opportunity to connect globally. Yeah. So while I have a lot of experts available locally as well, and we will start tapping into that. One of the areas where Providence has benefited right now is we partner with, let's say, an Institute of Systems Biology, who are working out of location in Seattle. But they come up with their own research work on a day-to-day basis. But when we partner with them, we tend to understand what's happening next and how can we better apply it on our data. We also have many of the universities who are partnering with us, some of the genomics lab, as I had mentioned earlier. So we get to learn from many of these experts. And I think that is one of the things that drives us on a day-to-day basis, because here there is no end to the amount of learning that one can have over time, especially if we are tapping into the partnerships that we have available to us.
I think absolutely. I think that's why we see quite a bit of unicorns and everyone coming in, and we see quite a bit of university partnerships and startup partnerships that's happening very well across the industry, right? With that, that's it we have for you today. It was extremely thought-provoking session, and we had quite a bit of takeaways from your session. Thank you so much for your time, Preeta. It was absolute pleasure to host you. And to the ones who joined us today, hope you found today's session insightful. Thank you once again. Take care and stay safe.
Thank you so much for this opportunity.